So now the output resistance and the relation between these two things, R, whenever I say R suffix small m, it is without feedback. And R suffix capital M it is also without feedback, but I am considering the load. So usually all these current source, all these load and all will be connecting to the circuit externally, right? So it is not actually present within the amplifier. Okay, so they are connected externally. So whatever parameter you are going to compute, it is going to be without considering the effect of the load resistance. So see here, both RM and R capital M are without feedback, but R suffix small m is without RL, and R suffix capital M is considering RL. So I can write when R suffix capital M expression, if I put limit RL tends to infinity, I'll get back my trans resistance without feedback, without load. And R suffix capital M is trans resistance without feedback, with load. So that is the difference between two. And the unit of RM, it is a resistance, so it will be in ohms. Unit of RM will be in ohms. So we have found that the input impedance is decreasing for voltage shunt feedback amplifier. Now for finding the output resistance. So the way this step we have been doing, we'll be removing RL. So for finding the output resistance, disconnect RL and you assume that you are going to apply an voltage source capital V at the output side. And the current flowing from the voltage source is capital I. That is denoted here. And whatever input I have to make it 0. So IS equal to 0 means I'm going to open the current source, or I can remove the current source from the diagram. Okay, so these steps we have been doing from the feedback type. So remove your load because it is an externally connected component. So disconnect your load, or assume that you open circuited your load, then connect a known voltage source capital V, and that will generate a current capital I. V by I is going to be your output resistance. On input side, I have to deactivate my source. If it is voltage source, I'll be replacing it by short circuit. I'll put Vs equal to 0. If it is current source, I'll be replacing it with open circuit, or I can say Is equal to 0. So that is what is given in steps here. So you can see you can apply KVL here. Assume that, see, general logic is when you have two voltage source, the current will always be assumed to flow away from the voltage source. So the current from RMIA will be flowing like this, current from V will be flowing like this. So both are opposite. We assume that the value of V, what we apply, is very large. So effectively, the will be flowing only in this direction. Okay, so I is equal to V minus RM VI by R naught. So it is starting from V, the currents are opposing, so V minus RM II, it is II. Okay, V minus RM II by R naught. R naught is only resistance I have because I have disconnected my load RL. And you know that at the input side, we have already written the KCL equation. At the input side, you see Is equal to II plus If. This Is is 0 now. So II equal to minus If. Okay, II equal to minus If, and If is equal to beta V naught, and V naught is replaced by V. So I can write II is equal to minus beta V. II is equal to minus beta V. Okay, now substitute that in the whatever KVL equation we got in the output side. So I is equal to V minus II. V minus of minus Rm into II is beta V. So V minus of minus Rm into beta V by R naught. Minus of minus will become plus. So V plus beta Rm V by R naught. Take V outside. V into 1 plus beta Rm by naught. Now cross multiply. We want the ratio V by I. Because V by I is going to be R naught F, which is going to be the output resistance of the amplifier with feedback. So rearrange the term. You can get the output resistance of the amplifier with feedback is R naught F is equal to V by I. So if you cross multiply and rearrange, you get R naught by 1 plus beta into Rm. Here also you see I'm getting R naught is the output resistance of an amplifier. It is divided by 1 plus beta into Rm. So my output resistance is also logically decreasing. This is acceptable for me because for any amplifier, the input resistance should be very high and the output resistance should be very, very small so that the effective power transfer takes place. Okay, so RIF is R naught F is decreasing here, and mathematically we have seen that RIF is also decreasing. That is not good, but output side I'm okay because R naught F is decreasing, which is very good for me. And as usual, this RM, RM is without feedback, without RL, and R capital M is without